Hey guys, and welcome to the video. So today I decided to make a video on how to solve a key problem you will receive if you choose to create a character controller using a rigid body instead of the character controller built into Unity. Now the character controller can do great things like being able to walk up and down stairs, whereas the rigid body cannot do that. For most people, the character controller will be fine, but me personally, and for many others, sometimes either a rigid body just makes more sense for the style of game, or you just prefer to work with that as it's easier to code with and it's what you're familiar with. So, what I'm going to show you how to do now is how to use a rigid body character and still be able to go up and down stairs. Now, most people's solutions tend to be just going up and down ramps. Now that's all well and good, but sometimes you actually need to be able to go up and down stairs. So I've got 3 stair examples here. I've used ProBuild to make these. So for example, this stair over here, I've made it convex so that it is basically like a ramp. So with a character controller without any additions, you will be able to go up and down this. These set of stairs are regular steps, and I've got some spiral stairs here, which is where I'll show that just making it convex doesn't quite do what you would want, so that's not an option. So if you've got any kind of curve to your stairs, then you're not going to be able to do the ramp trick. And then there's these blocks, and I'll show that these blocks will actually block your movement, except for the small one here, and that is not ideal. So if I show you what I mean, I've currently got the tutorial unfinished script on, and I can show you that as you run into these simple blocks, you just get caught on them. Now, this isn't ideal, and you don't want to have to go and create a little ramp for every little object. So if I show you what I'm going to have complete by the end of this tutorial, let's load up the completed one, and you can see that as I run into it, you run over it, and you can run up and down stairs. If we go over to these stairs here, regular stairs, you can go up and down these, and to show you that it also still works on ramps as well, you can still go up and down ramps just fine. So if we go back to the tutorial script where it is broken, I can now show you just how it is we do that. Okay, so basically the general idea is we're going to use 2 raycast points to check if we're colliding with an object and if it's something we should be able to step over. So the idea is we're going to create a raycast point at the bottom of the feet and a raycast point, say, near the knees to determine whether you should be able to climb this or not. Right, so the easiest way to represent where these raycasts are going to be are just 2 empty game objects. So I've created step ray lower and step ray upper. These 2 game objects are where the raycasts are going to come from. The upper one we will determine in script exactly where that's going to be, but the lower one you kind of just want it to be right down to the bottom, not quite on the floor, but just above. So the general idea is going to be that if we're colliding with the lower ray, we check to see if we also collide with the upper ray. If we do, then we don't want to do anything. We're just walking into something that's too high. If we don't collide with the upper ray, then it's something we should be able to step over. So if we go back and go into our script here, we can make a start. So we're first going to want to create some standard variables. First of all, we want to capture the empty game objects we've created for our raycast points. I've defined a step height float and a step smooth. The step height is how high we're going to want our character to be able to climb in a simple step, and the step smooth is what will sort of smooth our transition up the step rather than making it look too jolty, and it'll be how high we step up basically. So first of all, if we save that and go back, as you can see when this reloads in, we'll have our new variables. So I've got them set to serialized fields, but they are private, so they can't be accessed anywhere else, but we still have access to them in the editor. So the first thing we're going to want to do is define our step lower and step higher heights. Here's where you can change the values if you're going to need to. Okay, so the next stage is to take the step ray upper game object that we have defined, take its position and set its height to be the step height that we set in the inspector. This will allow us to adjust exactly how high and how tall the steps can be that allow us to climb them. Okay, so with that in place, it's time for us to actually create the function that we're going to use to define the raycast points and step up on the steps. So we'll do that by creating a new function. Right, when we have this new function, we're going to want to have this being called in our fixed update function. So there you go, that's ready to be used. Now, basically what we're going to do is we're going to create a raycast. First of all, we want to check for the lower raycast, as I was saying. We're going to create a new raycast point. It's going to stem from the game object position that we've defined. It's going to move outwards, look for an object that it can hit, and the distance. You can play around with these as much as you want, but I find that 0.1 is a pretty good distance. It doesn't go out too far, so you've got to be right up against the object for you to recognize. So the second stage is to put our second raycast inside that if statement. Now, the reason we're doing that is because it limits how many raycast checks we're going to be doing. So while we're running around the world and we're not colliding with anything, we're not entering the if statement. So we're only ever actually sending out this one raycast. If that raycast collides with something, then we know we're at an object and we want to check. So this is where we'll create the second raycast, the upper one, and it basically works the same. We are taking its position from the game object, sending it out forward from the character's position, but we do want to send it out a little bit further. This will allow us to step over anything that is slanted ever so slightly away from us. If they were set to be exactly the same, then potentially an object could be slightly slanted away from you. Not enough for it to be a ramp and you to be able to walk up, but enough that the upper raycast wouldn't detect it, and then you might not be able to step up it. So if you make sure that one sends out a little bit further, then any slightly slanted object, you also climb above. We want to set this to not, because what we basically want to check is if we are currently colliding with an object, we want to make sure that the object isn't tall enough for us to stop us completely. So we need to make sure that this raycast isn't hitting anything. If that's the case, then what we're basically going to do is we're going to take the rigid body of our character and literally just take the position and minus it by our step smooth amount. So that's why we have the step smooth amount. The higher the step smooth, the more your character will jump up. Now, because this is being done every update, you can set it to a really low value and it will smoothly move your character up. So if we take that and save, then what we can do, give it a quick test. And there you go. As you can see, we bump into the object and we move up and step onto it. Now, it's not completely perfect at the moment. For example, if I go at an angle, you can see that you kind of get stuck. You don't quite go up things, but in general, we can move up and down the stairs. So let's fix the angle. So what I've done here is basically replicated the raycast code from our forward, and I've set it at a 45-degree angle and a minus 45-degree angle. So we now have three raycasts going out. They will check in front, 45 degrees to the left, 45 degrees to the right, and they all work exactly the same. If any of them detect any kind of object, then they will send their upper raycasts out and see if there's anything that you can collide with at all there. So if we go back, we hit play, then you should be able to see that now, even if we're going at a bit of an angle, we can still go up and down the object perfectly fine. As you can see, you can go downstairs, it still works perfect. And also we can still go up and down ramps, so that works fine as well. And more importantly, these little blocks that get in the way, you can go up and down these and you smoothly go up and down. So to show you what some of these settings do, so the smoothing is how high up you go. So if we were to set this to some wild value like 1, then you would see that basically when we go over something, we jump up in the air way too much. And that's being done for every physics update that you are colliding. So if we set it down to 0.01 and go in the opposite direction and make it really small, you'll see we'll climb up much slower because every physics update, we're only jumping up a tiny amount. Now, that's too low because it kind of slows the character down and it really feels like he's struggling to go up them. It looks even worse on stairs because you hit the stair before you actually get up there. But something like 0.1 works quite well, and you kind of just sort of, you look like you almost just step onto the top of it and you go straight over it. As for the step height, if I show you that I cannot climb up the 2 double stairs there, I can't go up there, but the single stair I can. If I was to set this to, say, 1, then that would make the step height really tall, and I would be able to step up onto the double stairs there, maybe even onto the triple stairs. I just about make it up that, but I can't make it up there. If you were to make it, say, 100, something really ludicrous, then you can see that whole platform in the background. I would also be able to just climb straight up. So if we go straight up it, as you can see, might take a little bit of time, but in general, you should just climb right up it. Now this works very similar to the character controller. There's some slight differences. It may not be the most optimal, but it's a clean, simple solution that I have personally found to be able to climb up and down the stairs, and more importantly, any kind of rocks or curbs you may have in your game. It allows you to go up them without having to take every single object and create some kind of ramp for it. You can just have a box. As long as it's low enough and you set your step height to enough, then you can go up and down it. So there you go. That's how to climb up and down stairs with a rigid body in Unity. Thanks for watching the video. Like the video if you liked my solution. If you've got any suggestions for better ways to do it, then please let people know down in the comments. And if I find your solution better than mine, I might even heart it and pin the comment so other people can see that one instead. Thank you very much, guys, and see you next time.